Hi, Phil.
Hi.
Thanks for joining us today. It's a great pleasure for me that we've been able to win you as a session chair for our panel discussion on the future of the offshore pipeline industry. Phil has held technical and business leadership roles at Xodus, Herima, Intexi, and KW Limited over the last 20 years. He now leads the Subsea and pipeline team at Petrofac. Current projects include design of onshore and offshore pipelines for hydrocarbon, hydrogen, and CO2 service, subsea decommissioning, and support to field development studies. Thanks again for joining us today, Phil. The floor is yours, please.
Thank you very much. Yes, pleasure to greet the colleagues here today. And I'm not sure where they are, but I guess that they'll appear right on cue. So we're very lucky to have some good experts joining the panel today, along with Greg, who you've already met on screen at least. So starting with Carsten Schütt. He's technology leader at Evonik operations in Germany. He has a master's degree in process engineering at Martin Luther University in Germany, and 10 years experience of R&D in the polymers industry, which is really interesting in the increased application of polymers to pipeline projects. So functional experience includes R&D, testing and application technology development and polymer processing as project and team leader, mainly focused in development work for the energy market in high performance polymers and semi-finished products like unidirectional carbon fiber tapes. Recently moved to R&D projects portfolio management and tech scouting for industrial and energy. So right now he's technology leader, industrial and energy, responsible for directing and managing the R&D project portfolio of the industrial and energy segment. So lots of experience on the realities of applying polymer materials and the new breed of high performance polymers to applications like pipelines. So great to meet you, Carsten. And moving on, I can find the right button here. Rafael. So I've lost Rafael's bio, but I know a bit about Rafael. He's a very senior subsea pipelines consultant at Petrobras. So he's right in the middle of the surge of activity going on deep water Brazil right now, with fields like what was the Libra field is now Miro. So Miro 1 project is fully going. Buzios 5, I think they're up to now, and a whole stream of more Buzios FPSO projects, and another number of other really frontier deep water hydrocarbon production projects in the pre-salt deep water fields offshore Brazil. So Rafael's a technical expert right in the middle of the hottest spot in offshore pipelines around the world. So we're very, very fortunate to have Rafael joining us from Brazil today. So Greg, please elaborate on your background before I didn't quite catch your introduction, but I guess that was covered earlier.
Yes.
Yes.
I suppose very briefly, over 30 years experience, covering everything through from R&D through construction or design, construction, operations, and then abandonment and mothballing, onshore and offshore, predominantly offshore, predominantly North Sea, but stints in Australia and in East Africa. So yeah,
fantastic.
Fair breadth.
Yeah. So and Rafael, what did I miss in your introduction?
It's nice.
Yeah.
Very nice. I believe that I work in Petrobras is the most of subsea pipeline in deep water.
Yeah.
And very nice introduction. Thank you, Phil.
Okay, thank you. And Carsten, I must confess I'm not so familiar with Evonik,
Right.
although I've been following closely the adoption of high performance polymers across the sector. So please tell us a little bit more about your role in Evonik.
All right, thanks. What can do? So Evonik is a provider for high performance polymers. Well, it's just a section of our overall global business, but especially in the high performance polymer sections, we provide materials for onshore and offshore applications. So let's say material classes, thermoplastic polymers and composites in terms of polyamide materials, polyether ketones for very high temperature, high pressure, and let's say aggressive chemicals. I would call them aggressive chemicals. Applications in that regard, especially when we look at in the direction of Petrobras and, as you say, the hottest spot at the moment. We see what the parameters of the applications are there for flexible piping, especially, and those pose in combination with the high water depth real challenges for polymeric materials as sealings, as liner materials in this regard, and also as reinforcement materials as the composite state.
That's great. So the products you supply end up being incorporated into industrial products from flexible pipe suppliers. Do you supply sort of TCP pipe suppliers like Airborne and Magma and those people?
Right.
Yeah, and there's some onshore products as well where we've seen some increase. I mean, there's the conventional low pressure gas pipelines, but it's going into much higher pressure applications now, and
Correct.
spoolable polymer products. Yep. Maybe a little bit more expensive to buy than steel sometimes, but when you look at the overall life cycle cost, there's potential substantial savings. Very good. Thank you very much. So I'm going to kick off with a few questions for Greg. I caught most of your presentation, Greg, and of course I spotted on LinkedIn when your publication came out, and we were all crawling all over it in Petrofac, and it's in our library. So thanks very much for publishing that. That's really appreciated. So in terms of your sort of current work, as far as the sort of hydrogen backbone for high pressure gas transport, where do you see the gaps? What do you think the current technology development requirement is for getting high pressure hydrogen into the UK gas main?
Well, actually, the area I've been looking at is getting hydrogen produced by renewable sources in Scotland into Europe.
Oh, okay.
So the Scottish government has actually provided NZTC with some funding to look at that. So at a very high level, we've started looking at where the issue, we've determined the scope, and we're now starting to sort of work at the next level. It's interesting, conversations with NEL, National Engineering Laboratory, who lead sort of flow meter work in the UK. They've done a lot of work. They've got their own list of gaps, but the gaps depend on what size pipeline you're talking about, and what pressures you're talking about. So you kind of, in order to pin down where the real technological gaps are, we're having to actually look at what we think the route from northern Scotland, where a lot of this hydrogen is due to be produced, to Europe actually looks like. Is it going to be all pipelines? Is it going to be ships? Is it going to be a mixture? I think there's a reasonable chance it's going to be a mixture. we're kind of having to answer all those questions in order to be able to really focus in. But other than the flow meters, we're talking compressor technologies. We're talking valves and valve internals again, being major issues.
Very good. And
wherever you look, you can find an area where people don't have the understanding.
Okay, that's great. Thanks. I'm gonna move on. I think we've got a little bit of a bandwidth problem, Greg, on your line. The sound's breaking up a little bit, so we'll give you a break for a minute and hope that sorts itself out. And I'm gonna move on to Carsten, and maybe you could give some insight in where you see the application of polymer-based pipeline products in the energy transition, in CO2 and hydrogen transport.
Right. I think maybe interesting point is that many challenges arise for, let's say, repurposing of existing lines coming from the metal domain. They are still facing, let's say, uncertainties with regard to H2 embrittlement topics, especially with regard to weld lines and all this kind of stuff. And of course, those are intrinsic to the metallic sides. And polymers in that regard can be capable of addressing those applications on their own. Say if we talk about low or mid pressure ranges, or even at a high pressure range when we talk about reinforced pipes. Those can be monolithic systems in the case of, let's say, TCP, or unbonded systems as an RTP, with also reinforcement layers that are insensitive to these special types of failure mode that are induced by H2, for instance. On the CCUS side, we also can potentially outfit existing or repurpose systems with linings, so steel pipelines with linings to protect against corrosion and abrasive corrosion, as you can see it by dense phase transport, CO2 dense phase transport, where let's say a polymeric lining could bring benefit in terms of protecting those lines when we talk about corrosion prevention, but also to rehabilitate existing pipelines.
Right.
So pushing decommissioning a bit out, and also putting those corrosion topics to the back and saving substantially, and maybe in the OPEX.
Yeah.
So
on that rehabilitation aspect, is that something you think is applicable offshore as well as onshore?
I know that there are projects have been conducted by notable companies like Baker Hughes in shallow water applications of repurposing existing corroded steel pipelines by, let's say, getting an RTP installed of those. I'm pretty sure the RTP could do the job alone without the steel pipe, but of course it's then a decommissioning question.
Yes.
But it's definitely a chance. In this case, the RTP or TCP could even take the structural part. Whereas if we talk about lining with a neat polymer alone, you would be then limited to the intrinsic pressure capacity of that polymer system.
Right. Yeah, that sounds very interesting. I mean, the challenge of inserting a liner through a long length offshore is,
Yes,
not insignificant, but it's hard to.
It's done for water systems, right, offshore as well already. So,
right.
But it might also be applicable for.
That sounds like something I need to find out more about. That sounds very interesting. Okay, thanks, Carsten. So moving on, Rafael, do you think you could tell us a little bit more about the development of technical solutions for flow lines and risers in ultra deep waters? And that's really where you're at now.
Yeah, of course, Phil. Thank you. I'm preparing to talk about some topics but I will talk first. I would like to start to remember a fact some years ago, Vancouver, Canada, 2008, in a technical section from a well-known international conference, when my manager had stated the Petrobras challenge scenarios. He highlighted the Subsea pipeline project at offshore in more than 2,000 meter water depth, high pressure, high temperature fluids, soil service condition. And then when he finished his explanation, the session chairman simply said, "Good luck, Petrobras."
Yeah.
Nowadays, about 13 years later, Petrobras has several subsea pipeline in operation, overcoming each challenge. The question is how. But in terms of future of the offshore pipeline industry, the subsea pipeline system, Petrobras has a lot of challenges related to develop offshore fields in ultra deep water. I think that this will continue as great technical issue once 3,000 meter water depth is appearing with a new frontier for subsea pipeline, subsea developments along the Brazilian coast. In my mind, I think that the main topic is of the pipeline future are, in addition to ultra deep water pipelines, CO2 pipelines, hydrogen pipelines, digital transformation, material, of course, as well as life extension and decommissioning for all the offshore pipeline system. Regarding the material or alternative new materials, sometimes it will be require the resistance material against corrosion due to the contact characteristic, and also resistant material to the high environmental loading. For the new pipeline, digital transformation is a reality we will support so much for the overcoming the future challenge. But in terms of your questions for the ultra deep water operation, it is similar when you compare what's occurred some years ago. However, of course, it is much more challenging. It is a new technology frontier concern development in deep water, ultra deep waters in case of offshore Brazil, and how to overcome the challenge for ultra deep water pipeline. I believe that it is very similar to the past, with a new technology solution based on research and development initiatives, new technology qualifications, other concepts of risers and pipeline in similar way to concept already adopted, like steel laser wave riser, hybrid risers, and pipe system were recently designed and qualified and installed. New materials or alternative material for internal metallic liner with corrosion-resistant alloy. Nowadays, Petrobras has used mechanical lined pipe and clad pipe, both with Conel 625. In terms of design, focus on strain-based designs for engineer analysis solution, and to start a massive use of digital solution, mainly for pipeline design and subsea layout definition.
So historically, I mean, Petrobras has been famous for doing fast track and very cost-effective field developments using standard flexible riser and pipeline solutions, and that has started to change in recent years with a more preference for rigid pipelines, following some concerns with CO2 particularly. So
Nowadays, the rigid pipe is a base case solution to develop some subsea systems. The solution for the flow line are based on the initial primes or base case of anchor the flow line ends at the plate next to the well at the flow line and rises transition, just reduce interface with wellhead equipment as well as with rise section, make installation easy in some time, simplifying the design and installation of a rigid spool, also avoid the pipeline walking behavior and looking for several control the lateral buckling solution, include the residual curvature methods. For example, in terms of riser, the technical solution depends mainly on the well positions and consequently of the subsea layout for the Brazilian Pre-salt project, include Med 1, Sepia, Buziocico, for example. Steel laser wave risers has been the adopted concept, is the most case linked to the subsea well directly to the platform.
Right. Moving on from the CRA-lined rigid pipeline solutions that seem to be favorite in Brazil right now, do you see opportunities for alternative materials like more polymer-based high-performance polymers in future developments?
Yeah, for the line pipe material, nothing's new. Grade of carbon is still higher than API X65, has already been used. Challenges for qualification of the line pipes and welds will be to supersite for ultra deep water application. For internal metallic liner, corrosion resistant alloy with the alternative material to the Econel 625 is required. Petrobras has R&D projects for mechanical lining pipe with Econel 825 alloy and stainless steel too, in order to have a more alternative and to reduce the cost.
Yep.
Other R&D project has focused on polymeric liner together with suppliers like Evonik and installation companies. First of all, for water injection flow lines, but with other filter steps for application in risers and other pipeline functions such as oil production. In addition, flexible pipe are always an alternative to be considered by Petrobras and Great East for had been employed in order to make available this technology.
Yeah, fantastic. Thank you. Watch this space. So I'd like to move back to Greg now, if I may. And Greg, on CO2 transport, what do you see? What's your biggest concern and issue around repurposing an existing pipeline for CO2 transport?
The biggest, believe it or not, the biggest concern is actually understanding when you say CO2 transport, what do you mean? Because there's a tendency, for everybody to talk about dense phase, but actually there's probably going to be more pipelines that are suitable for transporting CO2 not in dense phase than there will be that are suitable for dense phase. And then there's that continual complication with CO2 where a small change in impurities has a major change in behavior. And that really means that before you can fully understand what is the pipeline suitable, you actually have to understand what the composition or composition ranges are that you are talking about for the CO2 you're going to be transporting. And for some projects that in development at the moment, they're taking their CO2 from one source. So relatively straightforward to understand what the composition is really going to be. But if you look at other projects like, Northern Lights in Norway is the obvious example, it's planning to take its CO2 from so many different sources that understanding exactly what the composition is going to end up being by the time you put it in a pipeline is actually not a straightforward exercise.
So the composition, and we're talking about high, like 95 to 99% CO2, and then impurities for the balance. And is your concern about those impurities around corrosion or around understanding the phase envelope and the
corrosion, the phase envelope, the behavior of any elastomers and valves,
right,
or to be exact, what does the CO2 do to the elastomers it encounters? Given, especially in the dense phase, it is a very good solvent. But that also, when you're repurposing a pipeline, that may impact how clean you have to get it. If you pick up a lot of stuff in the pipeline and put it into your reservoir, are you going to plug the reservoir? I don't know.
Yeah.
But it may, but again, you come back time and again, you've got all these issues, but trying to understand what the real issue is in a particular application, you keep coming back to, okay, but when we say CO2, exactly what composition are we talking about, or what range of compositions?
Yeah.
Getting that understanding is not straightforward.
No. And your point about dense phase, and there'll be more pipelines suitable for gas phase than for dense phase, repurposing. But if you're transporting offshore for injection through a subsea well, you've pretty much got to go dense phase, because you need dense phase to get into the reservoir. The pressure you need to get injected is
exactly, and that but you're then into the situation, if you were looking at one of the applications where there was a platform that was convenient, you could actually be looking at compressing and going into the dense phase once you're on the platform. So this is where, when you start to look at the detail, sometimes the repurposing doesn't look as attractive as it first did.
Yeah, I suppose the point is the not having the capacity to take dense phase pressure may not be a total deal breaker if you've got a platform available where you can put compression.
Yes,
but obviously the economics become a bit more nuanced. They
do, but and it may swing you back towards, well, actually, it's worth investing in a new pipeline after all. But it's like any, project. You've got to look at the full width to understand where you're going. But more than, shall we say, conventional oil and gas projects, actually getting a handle on what composition you're really talking about very, very early is essential to understand what's going to work, what's not, and where your economics really are.
So we're going to start seeing like a CO2 spec for reinjection, just like we have a gas spec for entering the grid. Tight limits on impurities.
Well, it's going to. The problem is the tight limits then impact the economics as well. Because you shift the costs around. You don't actually remove them.
No.
And that's other work that NZTC is involved with is actually working on contributing towards developing a scope for a JIP on how to write a CO2 spec for a CCS project, basically.
Right.
And that's been kicked off by some operators, and the work, the actual sort of proposed scope for the JIP and extending that to others should be out fairly shortly.
Right, that's good. And then I guess there's a lot of research needed still on, what different cocktails of CO2 might do to different materials in terms of corrosion.
Corrosion. There's research still needed to get your modeling software.
Yeah. Olga struggles a bit with CO2.
Yeah. So it's one thing talking about the materials and that sort of thing, but when you're still struggling to get your modeling software to work, you've got a lot of unknowns.
Exactly. Yeah. So all solvable, but it's not as straightforward as it might appear at first sight.
That's exactly, and it's all down to this irrational behavior of CO2.
Very, very, very good. Okay. Thank you. So Carsten, I noticed there was an announcement a few days ago that Strom have struck some kind of collaboration agreement with one of the offshore wind turbine suppliers for, I think it was it Siemens for a hydrogen export. So basically looking at producing hydrogen on the turbine, on a floating turbine, and using a Strom TCP riser and pipeline to export hydrogen instead of electricity. So do you see that as a strong opportunity for your business?
I think so too. Especially, I think we need to break it down a bit and distinguish between floaters and anchored, or what do you say, sea floor-bed manifested monopile structures. So talking about, do we need static pipes or dynamic pipe applications? So Strom has made its strategic shift to the energy transition topics and pronounced as much, and as you've seen with the press release with Siemens Gamesa, moving the direction pretty progressively. They have those PE glass fiber based systems, which I think are perfectly suitable as a static line to export H2 from a decentralized production offshore. Foregoing then all, let's say, energy transmission via thick subsea cables, lots of insulation, lots of materials going in there, lots of copper or whatever. But taking the pure gas, when you move the same application to a floater, you have to consider dynamic load cases for the pipes. And I think probably a glass fiber based system might not be that suitable for that anymore. But you could potentially move then to a carbon fiber-based system, as we've recently qualified according to F119. There are certain GIPs out there from DNV that specifically look in that direction, how to use polymeric reinforced pipes for H2 service. So more or less expanding a bit on the F119 approach. So yes, I think the TCP technology is especially suited for this type of applications, from low mid-pressure ranges even to high pressure ranges, by making a good selection of the materials incorporated, foregoing all corrosive aspects, and being spoolable and deployable at long length.
With not such a big boat as well. I mean, that's the
right
one of the aspects of the adoption of polymers in pipeline applications in place of more conventional steel products is the reduced vessel requirements, which is, not such good news to a lot of the incumbents, but I'm sure they will adapt and address the challenge. But it's certainly going to create changes if some of these grand schemes actually turn into reality, and we see a network of TCP hydrogen pipelines across the North Sea, gathering hydrogen from offshore wind turbines and feeding them to UK, Germany, Denmark, Belgium, the powering half of Europe potentially if you went to the ultimate goal. It could be a very different fleet emerging as a result. And so, Rafael, coming back to you, I noticed as well there was some kind of a JIP that it's concluded with Strom again, or Airborne as was. I believe it's with Shell and Petrobras on qualifying their TCP product for deepwater risers in Brazil. So are you involved in that activity at all in your position?
Unfortunately, I'm not involved in this project, but I believe that it's very interesting project.
Yeah,
but I'm not involved.
Yeah, yes. I mean, that'll be interesting to see how that goes, because again, it's top tension is one of the big drivers for your rigid steel riser requirements, and top tension is almost nothing with a thermoplastic product. It's you can maybe even do it with a PLSV.
Yeah.
So it'll be interesting to see again the impacts on the makeup installation fleet. 10 years from now, if some of these products start to get adopted.
Yeah.
Another development that I've heard about in Brazil is around some of the older flexible production pipelines and risers, where there are concerns or even anomalies identified where replacement might be needed. And there's some thinking going on around perhaps alternative materials and construction methods to replace old flexible risers with new products, maybe mechanically jointed, maybe thermoplastic, maybe rigid steel. Do you have any comments on that development?
Nowadays, the basic case for Petrobras is to use for reach the pipe in order to put in substituting a flexible pipe, and with the platform is not to prepare to receive the rigid pipe in terms of a top connection, and so have some device in order to adapt this connection. And nowadays has a TPT project that use a segment of a titanium tube in order to perform this interface between the rising platform. This is the basic case of solution for Petrobras today.
Okay, that's another aspect. Is the balcony is going to be, if you were designing a balcony for an SCR, it wouldn't look the same as for a flexible. So how do you make the two work? It's a
big challenge.
But the implications there again is the high spec international relay, J-lay, deepwater pipe lay vessels are going to be very much in demand for some time in Brazil. These are not standard kind of long-term charter activities. It's a high spec real ship or J-lay that's going to be needed for rigid riser deployment in 2,000 meters water depth, say.
Yeah. I believe that this is completely the other question for the audience is from Marcelino Guedes that ask if this is still a challenge. Yes, this continues still a challenge.
Yes. Yes, I'm sorry. I've only just seen the chat coming up. I was so engrossed in talking to you. That's a great question. So Marcelo Guedes Gomez has asked Rafael Solano, could you talk a little about what was developed to reduce the weight of risers on platforms? So when we say platforms, that's FPSO in the case of Brazil. So the hang-off weight. What was the solution? Is it still a challenge? So
this is still a challenge.
Yeah.
Yes. and try to use the resistance steel, increase the grade of the carbon steel, and to work a lot in terms of riser configuration and put the buoyancy in the rigid riser, and try to adapt the configuration of the risers. And so nowadays the steel lazy heavy riser is the focus on the technical solution to reduce this load.
Yeah, but last time I was in your office, there was some discussion around a thick coating instead of discrete buoyancy modules, having a low density thick coating along the length of pipe. Is that something that has progressed?
And I don't have the information about this, but it is a possibility to try to continue the R&D project in order to have a other alternative for the riser.
It's a complicated trade-off, because you change the submerged weight of the riser, and the dynamic behavior of the catenary changes massively, and the drag area increases. So there's a very complicated trade-offs.
Because you have a very challenging in order to avoid the interference clashing between the risers, between riser and anchor lines, and riser and umbilicals, and etc. In addition to this, the fatigue limit state is very complicated for some riser configurations.
It is. It's a really fascinating technical challenge, and I know the popular topic of conversation is around CO2 and hydrogen and all these things, but we must remember that, especially over in Brazil and other deep water basins, there are enormous technical challenges in delivering cost-effective and safe hydrocarbons, which we still need for many years to come. And I think where you are, you're right at the cutting edge of applying these kind of designs to really fantastic discoveries, lots of resources. Okay, and another question from Luca Santini. He would like to know, what potential do you see in using unmanned aerial system, big drones, for offshore pipeline inspections? Any proof of concept already kicked off, e.g. leak spills and detection? So that's an interesting one, an aerial reconnaissance drone for looking after offshore pipelines.
I think I can provide something here. The only work I'm aware of on the offshore side on aerial drones has actually been for looking for methane leaks and that around platforms.
Right.
It hasn't been targeted at the pipelines at all.
Oh, we're losing you there, Greg. I don't.
Yeah, just let's try.
If you kill your video, we might be able to hear your audio better, Greg. That might. I think you're struggling with bandwidth there in Scotland. But just an anecdote, really. There was one of my colleagues gave a talk a few months ago at the Offshore Engineering Society about some work in the southern North Sea. With one of the pipelines that we were involved with there for a major client had an issue with free span fatigue that they were aware of, and they weren't. They thought they had a little bit of time to fix it with the mobile seabed in the southern North Sea. Turned out they didn't. And the first they heard of it was when a helicopter was en route to a platform. They looked down and they could see a pipeline floating on the surface. So that was an example of aerial reconnaissance, but not. I think by the time you get to that stage, it's game over. And by the time they flew back, it had gone. It was in pieces. But it's an interesting thought. And one more question. I think we're pretty much running out of time. Greg, you're back now. Do you have any more comments on the aerial reconnaissance? Hello, Greg. He's on mute or silent, or the Scottish internet's having a bad day. Question from Belkacem Bechka. I'm sorry, I've probably pronounced that wrong, but understanding that offshore pipelines are laid between subsea production platform and the land facilities, how design is segregated between offshore and onshore sections to insert a beach valve on the shore approach. So I think the answer is yes and yes, but it's designed as a system. So yeah, typically we would see a different design code between onshore and offshore, or certainly some different factors applied, but there's typically an isolation joint and a beach valve, and there typically some segmentation in the contracting as well. So, but there's a lot that's similar as well. So thanks for that. So I think we're there. Greg, are you back with us? I think we've just passed our allotted time. So and we that was the last question from the audience. So I'd like to draw the session to a close. Thank our participants very much for joining us. It's been very instructive. Carsten, very good to meet you and hear about your work in polymers. Rafael, similarly, great to see the progress being made in Brazil.
Thank you.
Challenges that you still face, and Greg, that was really appreciated your keynote on the FAMICA approach for repurposing and the insights that you've shared with us today. So with that, I'd like to hand you back, ready for the next part of the summit.